Hello there, and welcome to this month's Science Saturday. I'm your host, Noah Mugen. I hope you had a wonderful April, and we're glad to have you back. Today we're going to be going over the science of how the seasons change, and I'm going to quickly go over the materials that we'll be using in today's experiments. Now, don't worry if you don't have all them, because it's easy to follow along and just watch the video. Today we'll be using a globe and a flashlight. Right now, we're smack dab in the middle of spring, which is really crazy to think about because just a few months ago, we were in the middle of snowvid. There was snow everywhere and it was super cold. I mean, you all remember that. But now everything is green, the flowers are blooming, and we're even getting a little taste of those famous Texas summer temperatures. The environment changed really quickly, very drastically. As you know, the seasons cause things to change in a cycle. Summer, it's warm, fall is kind of getting cool, winter it's really cold, and then spring, life is coming back and it's warming back up. The question is, why do they change like that? Well, that's what we're going to be talking about today. Now, if you were to take a vacation to Australia right now, what would you expect to see? Maybe some exotic Australian flowers, or maybe some people barbecuing on their famous beaches? Well, that would be nice, but it's actually the opposite. Right now, as things are warming up here, it's cooling down in Australia and they're getting ready for winter. While it's spring here, it's fall over there. In fact, this is true for anywhere in the southern hemisphere. If you weren't aware, the world can be divided into two regions, the north hemisphere and the southern hemisphere. As you can see, we live in the northern hemisphere and it's above the equator, which is the line that separates the two hemispheres. Australia is in the southern hemisphere. Among other differences, the two hemispheres have opposite seasons. Right now we're in spring, but Australia is in fall. Just a little bit ago we were in winter, but Australia was enjoying its nice summertime. It's hard to believe, but it really happens. Now this might seem crazy, but really it's crazy to think that there are seasons in the first place. I mean, why should the temperature keep going up and down while everything else is stable? Well, they can actually both be explained by a little bit of astronomy. First off, let's start with the Earth's spin. As you probably know, the Earth spins on an axis as it travels around the Sun. The Sun doesn't actually move around us, but it seems to travel through the sky as we ourselves spin. You can actually model this with either a globe or a simple, ball, a flashlight, and a room that you can make pretty dark. This flashlight is going to be our sun, and either the globe or the ball that you grabbed is going to be the Earth. Turn the flashlight on and shine it at the Earth. Now, turn the lights off. Make sure that you get the flashlight so that one whole side of the Earth is illuminated. See this? Everywhere that the light is shining, it's daytime. Everywhere that the light isn't hitting, it's nighttime. Now, start spinning the Earth. As we travel, we enter the light of the sun. And then it's noon. And then as we pass back into the shadow, we go into nighttime. We sleep through the night, and as the Earth keeps spinning, we enter the light again, and it's day again. This cycle happens every day as the Earth spins around the sun. Day, night. Daytime, nighttime. And on and on and on. However, there's something not so simple about the Earth's rotation. As you may have noticed, the axis of rotation, the line at which the Earth revolves or rotates around, isn't straight up and down. Instead, it's tilted at 23.5 degrees. And as we'll see in a minute, that tilt is what causes the seasons. As the Earth revolves around the sun, the axis of rotation doesn't change direction. So while here, the northern hemisphere is closer to the sun than the southern hemisphere is, over here, the southern hemisphere is closer to the sun than the northern hemisphere. You're starting to get the picture? To show the effects of this tilt, you're going to need the Earth and the sun again. Set the Earth up so that the North Pole is facing directly away from the sun. Now, shine a small beam of light directly onto the middle of the northern hemisphere. Make sure that the light isn't put right onto the Earth, but it's level with the table that the Earth is resting on. If you have a globe, then it'll be tilted at the 23.5 degrees. But if not, then you're going to have to remember that halfway through the ball at a tilted angle is the equator. Pay attention to how big the size of the light is on the globe. It's not really a circle, it's more of an oval. Now, bring this light down to the middle of the southern hemisphere. This exact same distance from the equator, remember. Now, the light is much smaller than the light is when it's put at the same distance in the northern hemisphere. It's very large right here, but as you bring it down to the same level, but just on the opposite side of the equator, it's much smaller. Now remember, this isn't all the light that the Earth would be getting. During the day, the entire globe would be illuminated, or at least the half that's facing the sun. We're only showing a small portion of that light to demonstrate how that light will interact with the curved surface of the Earth. Now remember, both the north and the south got the same amount of light. I'm not changing how bright this flashlight is. However, in the north, the light was spread over a much larger area than the light was in the south. In the south, the side of the Earth that's closest to the sun, the light is more concentrated than in the north because it doesn't need to spread out as much. Since the light is more concentrated, it's going to be hotter. So since the light covers a much smaller area in the southern hemisphere than the northern hemisphere, when the northern hemisphere is tilted away from the sun, the southern hemisphere gets a lot hotter. It isn't just because the north is a little farther away that its light is spread out more. Since the axis is tilted away from the sun, the area north of the equator is curved much more than the area south of the equator. When light comes in at the same angle to both hemispheres, it's forced to cover a lot more land in the area farther away, since the curve gives a lot more land for the same vertical distance. Right now, with the axis of rotation pointed away from the sun, the north is in winter because the light that it's getting is a lot less concentrated and thus a lot less warm, while the south is in summer since the light that it's getting is very concentrated. As the Earth moves around the sun, the axis of rotation stays at the same angle. Right here, both the north and the south are at the same curvature away from the sun because the axis of rotation isn't pointed towards or away from the sun, and so the light that they're getting is equally concentrated. This would be, the north is going to be in spring right now because it just had winter and now it's moving to the summer, while the south is in fall because it just had summer and now it's going back towards the winter. They're both around the same temperature because, again, the light is about the same concentration. Now, the Earth continues moving, but the axis of rotation stays the same, and we reach a point where the north is pointed towards the sun, while the south is pointed away from the sun. Now the light hitting the northern hemisphere is much more concentrated and thus a lot more hot, because remember, the circle of the light is a lot smaller than in the south, where the light is a lot less concentrated and thus it's a lot colder. If we were to continue on, the north would then go into fall as summer ends and it's back on this side of the sun. And then the south would be in spring as it's finishing up winter and coming back towards the sun. And then we'd be right back to where we started. The north is in winter, and the south is in summer. And this repeats on and on every single year as the Earth keeps going around the sun. As you know, the seasons are pretty much constant. We always have summer, fall, winter, spring, summer again, and then on and on and on because of this cycle. You can also use this experiment to explain why the Earth gets warmer as you move closer to the equator and colder as you move closer to the poles. Since the United States is in the northern hemisphere, that means that the south of the US is going to be closer to the equator and thus hotter. That's why Texas is a lot hotter than New York is. We can use the same experiment to show this. Just have the sun and your Earth. Shine the light right above the equator in the northern hemisphere. Then shine it a little higher. Remember that your flashlight is going to be held parallel to the ground. As you can see, even from the equator to halfway through the northern hemisphere, the light becomes a lot less concentrated. As we move up higher, you can see that the North Pole isn't even able to get any light because it's pointed so far away from the sun. While the North is in winter, the North Pole is actually in perpetual darkness, and it doesn't actually get day again until the seasons change. As you could see how the light got more concentrated closer to the equator and less concentrated away from the equator as the Earth curved away from it. That is why the Earth is just so much more hotter as you get closer to the midpoint, and colder as you get closer to the poles and Santa Claus. Now you can also have the same thing happen in the southern hemisphere. We're going to do the exact same thing. Point your sun just below the equator. See how concentrated the light is? Now, bring it down a little bit. The area that the light shines on becomes a lot bigger, but it's still there. Now, shine it all the way to the South Pole. If you'll notice, the light is hitting even beyond the South Pole, even though it's not very concentrated since it's covering a very large area. While the South is in summer, while any pole is in summer, its specific pole, whether it's the South Pole in summer, then it's the South Pole, or the North in summer, then it's the North Pole, it's always daytime there. It just doesn't become night because it's tilted towards the sun. It's only once the seasons change and that pole goes out of summer that it actually starts getting night again as the Earth starts revolving and it starts moving out of the sun's rays. And that's why the seasons change. The Earth's axis of rotation will change relative to the sun throughout the year, and thus the Earth is curved away from the sun at different angles in different seasons. That curvature makes the light of the sun more or less concentrated in different areas, making it more or less hot and causing the seasons that we know and love. Hopefully you love them. Well, that about wraps up another Science Saturday. I had fun learning about the seasons, and I hope you did too. Stay safe, have a great May, and I'll see you next month. Bye-bye.